The first part is that we're looking at cosine of x squared, and we need to show that that's greater than cosine of x for x between 0 and 1. So I have two answers for how we could show this. The first is the less mathy way, perhaps, but certainly a way that's going to be, it's probably going to be your go-to. And especially when you're working on homework, it's definitely the thing that would be my go-to. So I'm going to share my screen really quick because I have graphed this on Desmos. So on Desmos, you can see pretty clearly that that red line, which is our cosine of x squared, is above the blue line, which is our cosine of x. So I do think that graphing it is a reasonable way to show. And when you're working on the homework, that's what I would do. If you want an even mathier option, then the only mathy option that I could think of, and maybe somebody came up with a better one, but here are some mathy things that I know. On 0 to 1, x squared is always less than or equal to x. And I know that feels a little bit backwards, but if you think about a number between 0 and 1, like 1/2, if you take a half and then you square a half, you'd get 1/4, which is definitely less than a half. So on 0 to 1, x squared is less than x. So then the next piece, and again, this is a pretty mathy way to show that this is true, but the next piece of it would be to show that cosine is a decreasing function. So if I consider f of x equal to cosine of x, and I want to show that it's decreasing, well, now I'm thinking back to 17a, it's going to be decreasing if the derivative is negative. Well, the derivative of cosine is negative sine of x. So now it is decreasing on 0 to 1. And when we say 0 to 1 here, we're talking about 0 radians to 1 radian. And 1 radian is about 57 degrees. Calculus only works in radians, so these numbers, if we're plugging them into cosine, have to be in radians. And to show where I got that 57-ish degrees, 1 radian, if I wanted to convert that to degrees, that's 180 degrees per pi radians. And 180 over pi is about 3. It's a little bit less than 3. So if you put this into a calculator, you're going to get about 57 degrees. So at 57 degrees, we're definitely in the first quadrant, going from 0 to 57, which means sine has positive values in the first quadrant, which makes this derivative always negative on 0 to 1, which means that cosine of x is a decreasing function. Therefore, to get the larger values of cosine, we want the smaller things to be plugging into it. And because x squared is smaller than x on that window from 0 to 1, that means that cosine of x squared is definitely larger than cosine of x. That's the only mathy way that I could come up with. You can raise your hand in the chat or type something to me if you had a better way to show that. Again, on the homework, I'm nearly positive that what the book thinks you're going to do is to just graph them. So Desmos is a quick and easy way to show that. The second part of the problem asks us to look at the integral. So now we're looking at the integral from 0 to pi over 6 of cosine x squared dx. Now the truth is that even after we go all the way through 17b, we still won't have a way to integrate this function. It's called a non-elementary function, and we're never going to have a way to find the antiderivative of it. But we haven't actually been asked to evaluate this. We've just been asked to show that this is greater than or equal to 1/2. So because this all came as a part of one question, what I know is that the integral from 0 to pi over 6 of cosine x squared has to be greater than or equal to the integral from 0 to pi over 6 of cosine x. And this one we can find an antiderivative of. So again, our fundamental theorem of calculus tells us to do two things. First, the instructions, I've got my integral symbol and the dx, so whatever's in between those. These instructions say find the antiderivative. So I'm looking for who's the function whose derivative is cosine, and that function is sine. Then, notation-wise, I'm putting a vertical bar, and I'm going from 0 to pi over 6. The second part of the fundamental theorem of calculus says plug in the b and subtract off plugging in the a. While this is technically a correct answer, Dr. Dedell will definitely expect you to have all the special angles from the unit circle memorized, which means you need to know that sine of pi over 6 is 1/2. And that sine of 0 is 0.